This is a study of the current world record of distant landscape photography. It's taken in France from Pic Fenestrelle to Pic Gaspard. Total distance 443 kilometers. And here is the picture. Here is my screenshot of Google Maps showing the two mountains and the distance. This is a detail of Pic Fenestrelle, and its elevation is 2,826 meters, and I'm using the Wikipedia data throughout. Here is a detail of Pic Gaspard, and its elevation is 3,883 meters. This is a detail of the town that's right in the middle between the two mountains. This would be 221.5 kilometers from each mountain. Its elevation is 50 meters average per wiki. Now let's calculate the bulge height between the two mountains on the fictional globe Earth. AB is the distance between the two mountains, 443 kilometers. AD is half the distance, 221.5 kilometers, and DB is the same, half the distance, 221.5 kilometers. CE is the radius of the Earth in kilometers, 6,371 kilometers, and CB is the radius of the globe Earth. CD is our unknown. Using the Pythagorean theorem, we calculate the distance of CD, which comes out to 6,367.148 kilometers. The expected globe bulge is 3,852 meters. To the calculated globe bulge, we add the elevation in the middle between the two mountains, which is 50 meters. The total is 3,902 meters. Total fictional globe bulge. Here we see three red lines representing both of the mountains and the bulge in the middle. We see the total bulge in the middle is actually slightly taller than Mount Gaspard. The bulge in the middle is actually slightly higher, but I have made both the line for the middle and Mount Gaspard the same height. This actually favors the globe. The line representing Mount Fenestrelle is 73% of the height of Mount Gaspard. I've shown a ruler where 1 represents the height of Mount Gaspard. The height of Mount Fenestrelle is actually 73% of the height of Mount Gaspard. I have placed the line at 75% of the height of Mount Gaspard. This favors the globe model. Now we add the line connecting the peaks of Mount Fenestrelle and Mount Gaspard. As you can see, the expected globe bulge in the middle of the two mountains blocks the line of sight between the two peaks of the mountains. And as you can see in the actual picture, you can see much more than just the peak of Mount Gaspard. As we close this study, let us determine by how much the line of sight, mountain peak to mountain peak, should have been blocked according to the globe Earth model. This is a graph with the height of the lower peak, Mount Fenestrelle, subtracted from the height of Mount Gaspard and from the height of the globe bulge. Fenestrelle minus itself is 0. The bulge minus Fenestrelle is 1,076 meters. And Mount Gaspard minus fenestrale is 1,057 meters. We will now add the line connecting the peak of Fenestrale with the peak of Gaspar. Because Gaspar is slightly lower than the bulge, the line intersecting the bulge height is at slightly lower than half of its height. So the amount of blockage is greater than 1,076 meters divided by 2. That is greater than 538 meters. In English units, this is greater than 1,765 feet of blockage according to the globe Earth model. Again, we see much more than just the peak of Gaspar in the picture. Before I close, let's check my results with the Metabunk calculator. Metabunk has the bulge at 3,851.6 meters. My calculation was 3,852 meters. But I notice one oversight at the Metabunk calculator. The Metabunk calculator has no place for terrain elevation, which is required to calculate the total globe bulge. I'm sure that's an honest oversight. Going by the globe drop calculator, the drop would be 15,420 meters. The hidden portion, which is based on the elevation of the observer, which in our case was peak Fenestrale, the hidden portion should be 5,030 meters. Peak Gaspar is 3,883 meters. That means it should be buried by 1,147 meters, or 3,763 feet. Now, if we look at their so-called standard refraction calculator, the hidden portion should be 3,810 meters. Peak Gaspar is 3,883 meters, which means that just 73 meters should be visible. That would be just 1.88% of the elevation of the mountain. If I were to grant that we are viewing the top 73 meters of Peak Gaspar in these pictures, and the cause of that is refraction, then let's go back to our prior graph and get a visual representation of what would be happening with refraction. Remember, the bulge is higher than Mount Gaspar, and we aren't just seeing the peak of the mountain. We are seeing 73 meters down the peak. So the light has to travel up and over the bulge and then back down to the observer at peak Fenestrale. And the light arrives to the observer in a coherent, recognizable fashion. This reminds me of a game we would play when we were kids, where we would throw a ball over the roof of the house. We can confidently determine by the current world record of distant landscape photography that the Earth is flat.